Welcome to this comprehensive walkthrough of LeetCode problem number 102, Binary Tree Level Order Traversal. In this video, we'll explore every aspect of the problem, including its core concepts, example walkthroughs, edge cases, different algorithmic strategies, and in-depth code explanations in both Python and Java. By the end, you'll have a clear understanding of how to solve this popular interview problem, why certain approaches work best, and how to write clean, efficient code. Let's dive right in and fully master LeetCode problem number 102. Let's start by examining the problem statement for LeetCode problem number 102. You are given the root node of a binary tree, and your task is to return a list of lists containing the values of all nodes at each tree level, from top to bottom and from left to right within each level. Essentially, you need to output the result of a breadth-first traversal of the tree, grouping values level by level. Let's review the examples provided. In example 1, the tree is organized with 3 as the root, 9 and 20 as its children, and 20 having children 15 and 7. The traversal visits level 0 with value 3, level 1 with 9 and 20, and level 2 with 15 and 7, thus producing the output 3, 9, 20, 15, 7. In example 2, the tree contains only the root node 1, so the output is 1. Finally, in example 3, the input is an empty tree, so the output is an empty list. These examples clarify both the format and expected behavior for varying tree structures. Now, let's discuss the problem's constraints and important edge cases for LeetCode problem number 102. The number of nodes can be from 0 up to 2000, and each node value can be any integer between -1000 and 1000. You need to handle an empty tree, where the root is null, by returning an empty list. If there is only a single node, the output should be a list containing a sublist with just that value. For trees that are skewed to one side, such as all left children or all right children, the levels should still be output in the same grouped fashion. Node values can be negative or extend across the entire allowed integer range, but that does not impact how you traverse or group the values. Carefully accounting for these situations ensures that your solution handles all scenarios robustly. For LeetCode problem number 102, the conventional and recommended approach is to use breadth-first search, or BFS, with a queue to process the tree level by level. BFS allows you to visit nodes in the exact order needed, naturally grouping their values by depth. The alternative, depth-first search, can be adapted by tracking levels, but it requires extra logic to manage value grouping, making it more complex and less readable. BFS's queue-based process aligns perfectly with this problem's requirements, since it processes all nodes at one level before moving to the next. This makes BFS both efficient and easy to follow, especially in an interview scenario. While DFS works, BFS is more suitable and is generally expected for this type of level order traversal problem. Let's take a closer look at the algorithm used for LeetCode problem number 102. First, we check if the root node exists. If not, we return an empty list since the tree is empty. Next, we prepare an empty result list to store our answer, and we set up a queue with the root node to begin our level order traversal. The main loop continues as long as there are nodes in the queue. For each level, we immediately record the current length of the queue, representing the number of nodes present at this depth. Then, we iterate that many times, ensuring we process only the nodes belonging to the current level. For each node, we add its value to a list for the current level, and if the node has left or right children, we add them to the queue for processing at the next level. After processing all nodes at the current level, we append the level list to the result. This process repeats until the queue is empty, and finally, we return the complete result. The key insight is that each iteration of the main loop corresponds exactly to one level of the tree, so grouping values requires no extra complexity. Focusing on implementation details for LeetCode problem number 102, the queue can take several forms, but using a deque from Python's collections module is efficient due to its fast append and pop-left operations. It's important to create a new current_level list in each iteration to ensure that values from different levels remain separate. Always enqueue child nodes in left to right order, as this matches the problem's specified traversal direction. The process ensures that each sublist in the result corresponds precisely to a level of the tree, from top to bottom and left to right. This approach keeps the code clean, readable, and highly efficient for this use case. Here is the full Python implementation for LeetCode problem number 102. This code begins by defining the treeNode class, just as in the original LeetCode problem. The level order method checks if the root node is none and returns an empty list if the tree is empty. For non-empty trees, it uses a deque to efficiently track nodes at each tree level. The main while loop runs as long as there are nodes to process. Inside the loop, it determines the number of nodes at the current level, creates a list to hold their values, processes each node by appending its value, and adds its children to the queue for the next level. After each level, it appends the values to the result list. This structure guarantees that values are grouped correctly by level. The code is highly efficient, easy to understand, and ready for use in any interview setting. This is the Java implementation for LeetCode problem number 102, which follows the exact same logic as the Python version. The code defines a public class solution and a public method level order that returns a list of lists of integers. It checks for a null root, uses a linked list as a queue, and processes each level using a for loop with level size. Child nodes are enqueued in left to right order. Differences from Python include static typing, the use of Java's generics, and explicit handling of nulls. Otherwise, the approach closely mirrors the Python code, ensuring values are grouped by level and presented in the correct order. Let's go through a step-by-step example for LeetCode problem number 102, using the tree given in example 1. We start with the queue containing the root node, value 3. After processing the root, its children, 9 and 20, are added to the queue, and the result list contains one sublist, 3. At the next level, we process 9, which has no children, and 20, whose children 15 and 7 are added to the queue. The result now holds two sublists, 3 and 9, 20. Finally, we process nodes 15 and 7, which have no children. After the third level, we append 15, 7 to the result. The queue is now empty, so the final output is 3, 9, 20, 15, 7. This step-by-step process demonstrates how values are gathered level by level. Continuing the walkthrough, consider example 2, where the tree has only the root node 1. The queue starts with 1, processes the only node, and the result is 1, matching expectations for a single node tree. For an empty tree, represented as, the queue is empty, and the result is simply an empty list. Let's also cover a left-skewed tree where each node only has a left child, such as 1, 2, null, 3. Traversal proceeds from 1 to 2 to 3, resulting in 1, 2, 3, with each value on its own level. Similarly, for a right-skewed tree, the process is the same, resulting in each value occupying a separate level. These scenarios highlight how the algorithm robustly handles all edge cases and unusual tree shapes. For LeetCode problem number 102, the time complexity is O, n, where n is the total number of nodes in the tree, because each node is visited exactly once. The space complexity is also O, n. In the worst case, the queue may hold up to half the nodes at the last level, so both the queue and the result list will be proportional to the total number of nodes. While both BFS and DFS solutions are possible, they have the same complexities. This efficiency is optimal because we must process every node and store its value, which inherently requires O, n, time and space. Here are some practical tips and common variations to watch out for with LeetCode problem number 102. Related problems may ask you to return levels in bottom-up order or in a zigzag pattern. A common error when implementing this solution is to accidentally mix nodes from different levels, perhaps by not taking the current level size at the start of each loop. When working on variations, pay special attention to how values are grouped and ordered. In interviews, be ready to discuss these modifications and how your current solution could be adapted. Practicing with trees of different shapes and depths can help solidify your understanding and improve your coding speed and reliability. That's the end of this tutorial. I hope you found this explanation helpful for understanding the solution to this LeetCode problem. If you enjoyed this content, please consider subscribing to the channel for more coding tutorials and solutions. Feel free to leave a like if this video helped you, and don't hesitate to comment with any questions you might have. Thanks for watching, and happy coding!